Well, this is week 4. We've been talking about algorithms, and in this tutorial, we're going to talk about one of those algorithms. If you just go to tutorial for week 4, we're going to talk about selection sort. Okay, it's one we did talk about in lecture in the notes, and we're just going to go through an explicit example, and we're going to do so pretty fast because we did already talk about this, quite a lot. Now, the idea of selection sort is that you've got an array, and you want to sort, let's say, the integers in it in numerical order, small ones on the left up to the largest one on the right. The way this algorithm works is that we go through an array and we identify the smallest element, and once we identify it, we've started at a particular element, like the first element in an array, and we swap the smallest one we found with the smallest with the one we started with, and we do that iteratively, always starting at the starting point plus 1 for each round that we go through the algorithm. Pseudocode is that we define a condition that we repeat this until there are no unsorted elements that remain, and we search the unsorted part of the data, so the address in plus 1 to the right, until we find the smallest value, and then we swap the smallest value we found with the first element of the unsorted part. So it's quite a simple algorithm, and we did talk about this a lot. So this is a real simple array. We're going to search through it and find the smallest element. In this case, it's 1. We started at 5 on our first pass. We always start at the first element. So we're just going to swap 1 and 5, which we've done here. And then we're going to click over and start at 2, our first element. Find the smallest element in the array, which itself is 2. And so we don't need to do any swapping for that. And so we search for the smallest element, find it with 3, change it with the first element of the unsorted part. Okay, we've got one more. We're going to search for the smallest element, which is 4. We're going to swap it with the first unsorted element and go to the last one and do exactly the same thing with 5 and 6. And now when we end up at 6, it's the last one, and so there are no unsorted elements that remain. Now, the worst case scenario is we have to iterate over each of the in elements of the array, and we repeat it n times. And this is because only one element, gets sorted on each pass. Best case scenario is that, it actually is exactly the same. We have to go through that process every time because we won't know that it's all sorted until we go through it per the algorithm. And for that reason, the efficiency is fairly low for this algorithm, n squared, and likewise the omega is also n squared. Now, I was thinking about the efficiency of this. That's how selection sorts works. I hope that example helped you think about it in some small way. That's all I have to say about that.